Hi everyone, factoring week 2. So we're going to talk about two other types of factoring. The first step of factoring though is to factor out a GCF. So that works for every single problem, okay? That no matter what the problem is, the first thing you should be doing is trying to factor out a GCF. Once you factor out the GCF, now we can look at the difference of two squares or factoring by grouping. So the difference of two squares is when you have difference, which means you've got subtraction of two numbers being squared. It's always a binomial. Okay, you're always going to be using binomials for this, which means you've got two terms that are added and subtracted together. Or in this case, they have to be subtracted. And you're going to realize that they're going to be squares, like x squared is x. 25 is 5 squared. So we're going to kind of talk about what that would look like. So that's the first thing, but it only works for binomials. So I see that I have a binomial here, and I see that I have 25. 25 is 5 squared. X is obviously x squared, and I've got the difference, so I have subtraction. So the trick for this is it factors into x, because that's what's being squared, plus an x minus whatever is being squared to give you 25, which is 5. 5 times 5 gives you 25. And you could write it in that order, or honestly, you could write it in the other order. It does not matter. Some people always like to put the positive first. Some people always like to put the negative first, but it does not matter. And that's your answer. Let me check it by using FOIL or double distributing to show you that it does actually work out. So x plus 5 times x minus 5. So first is x times x, which is x squared. Outer is minus 5x. Inner is plus 5x. Last is 5 times negative 5, which is negative 25. The middle two terms cancel out because negative 5 plus 5 cancels out. Gives you x squared minus 25. So notice how these things match. So we are good. All right, so that's what the pattern is. So looking here at the second one, what's being squared, first of all, it's subtraction. It only works with subtraction. It's called difference of two squares. So what's being squared for the first term is your x. What's being squared with the second term is 2 squared. 2 squared is 4. So plus 2 minus 2. And once again, it doesn't matter the order. I'm going to FOIL it again so we can check it. So first is x times x, which is x squared. Outer gives me negative 2x. Inner is the middle 2, which is a positive 2x. Last gives me negative 4. The middles cancel out because I've got negative 2x plus 2x, and I end up getting the same binomial from before. This one, a little bit different. So 16 right away tells me this is 4 squared. I've got subtraction, so it's difference. This is actually x squared squared. Okay, so x squared raised to the second power. So when I go to break this down, it's x squared plus 4 and x squared minus 4. Okay, and you can check yourself real quickly by doing the FOIL method. X squared times x squared gives you x to the 4th. So you'll see in my notes, in my answer key, I'll write DOTS, difference of two squares, dots. Okay, I'll write dots, and then I will go through and show you what you get when you do the pattern, when you factor it out. Some of you might notice right away I have another difference of two squares here. This is another difference of two squares, and difference means subtraction. Not this one. This one's addition. I can't do difference of two squares with addition, just subtraction. So this can be factored into x and positive 2, x and negative 2, because 2 times 2 is 4. And then what you do is you just bring this other one down. Okay, so if I bring that one down, it doesn't matter the order you write it in. Your parentheses can be in any order that you want, but the x squared plus 4 stays there somewhere, then x plus 2, x minus 2. All right, and you can FOIL that out and do it to check, but I don't want to waste too much time doing that. These are a little bit different. So you have a leading coefficient. So far we haven't had any leading coefficients. This has been a 1, a 1, and a 1. Here you have a leading coefficient of 49. 49 is 7 squared. Okay, and 64 is 8 squared. So when you break this down, it's not just an x, it's a 7x out front. and then you have a positive 8 and a negative 8. All right, so that's your answer. And once again, you can have either order. You can have the negative 8 first, then the positive 8. I'm going to check it very quickly just to show you that it works out. So first is 7x times 7x, which is 49x squared. Outer, so that gives me 7 times 8, which is 56. So outer is a negative 56x plus a positive 56x for the inner two. Last gives me negative 64. Notice how the middle two cancel each other out. Negative 56x plus 56x cancels out. I get 49x squared minus 64, which is the same as what we've got up at the top. All right, we're going to do 2 more of these difference of squares patterns. Remember, they're just binomials. I can only do difference when there's subtraction and I've got binomials. Okay, 9 is 3 squared. 1 is 1 squared. So this is going to be 3 and an x plus 1, 3 and an x minus 1. Once again, you can have the minus 1 first. Going through to show you that this works, I'm going to FOIL it out or double distribute. 3x times 3x is 9x squared. 3x times negative 1 is negative 3x. 1 times a positive 3x is a positive 3x. Positive 1 times negative 1 is a negative 1. 3x plus negative 3x plus 3x cancel out. I get 9x squared minus 1. Works out. All right, let's look at the next one. This one is interesting, okay, because nothing squared gives me 50. Nothing squared gives me 72. But it is a binomial and I do have subtraction. That's because you should be able to take out a GCF. So none of these problems had any GCFs. Here I have a GCF and the GCF is 2. So I can divide these both by 2 and put 2 on the outside. Gives me 25x squared minus 36. Now I have my difference of squares. This is 5 squared, this is 6 squared. You have to leave the 2 out front. Okay, you need to have the 2 out front. But then my parentheses become 5x plus 6, 5x minus 6. Okay, and in lieu of time, I'm not going to show you what that would look like, but you can easily FOIL out the 5x plus 6 and minus 6, and then multiply everything by 2, and you're going to end up getting 50x squared minus 72. All right, I'm going to move on down here to a 4-term polynomial. When you have a 4-term polynomial, okay, so this is a 4-term polynomial only. So not a binomial. Binomial makes me think difference of squares. This is a 4-term polynomial. 1, 2, 3, 4. That's when you're using something called grouping, factoring by grouping. And what you do is you group. You group the first 2 terms together. You group the second 2 terms together. From these groupings, you factor out a GCF. So if I look here, x cubed, actually, you know what? I'm going to do different colors. I'll leave this color and this pink. So starting with my first 2 terms, x cubed and x squared, my GCF is an x squared. So I can divide these by x squared. It leaves me with an x and a plus 1. My next set, notice that the leading coefficient is a negative. You can't have a negative leading coefficient. So I'm going to pull out a negative 4. When I do that and I divide both of these by negative 4, it gives me x plus 1. It's not a coincidence that my parentheses are exactly the same. Your parentheses should absolutely match. Do you see how they match? That is your first set of parentheses. So what you're actually going to do is you're going to factor out the GCF of those parentheses. See how you have the same parentheses there? That means your first answer, because your answer is going to be a form of a couple binomials, your first answer is x plus 1. Then whatever's left over, that's your second set of parentheses. So your GCFs are your second set of parentheses. Your parentheses that are in common is your first set of parentheses. And once again, order doesn't matter, so if you have them flipped, that's fine. All right, so you group the terms, you factor out a GCF, you factor out the parentheses, x plus 1, and your parentheses should match. If they don't match, you did something wrong, like maybe a negative, so go back and check. Factor further if possible. That means you're looking for the difference of two squares, the dots. I do have a difference of two squares right there. X squared minus 4. That's 2. Okay, so this is x plus 2, x minus 2. And then I'm just bringing this one down. The x plus 1 gets brought down. So that right there is my final answer. Okay, 3 binomials. Every once in a while, factoring by grouping will leave you with 3 binomials. Sometimes factoring by grouping will leave you with 2 binomials. So let's do a couple examples. So I see that I have 4 terms. So 4 terms means I have to factor by grouping. I group my first 2 terms. I group my second 2 terms. Doesn't matter if you include the negative. It doesn't really matter. First 2 terms, factor out a GCF. My GCF is x squared. If I divide by x squared here, you're going to get x minus 1. Second set of parentheses, my GCF, since this front number is negative, my GCF is going to be a negative 9. Divide these both by negative 9, and you're going to get x minus 1. Notice how my parentheses are exactly the same. That's what I want. That is my first set of parentheses that I'm going to factor out. Okay, that's my first binomial. My second binomial is everything that's left over, x squared minus 9. Look for the difference of squares. I've got a difference here, but nothing's being squared. Here on my second set of parentheses, I have a difference of squares. Okay, this can factor out, I'll put dots here, into x plus 3, x minus 3. And you have to have an x squared in order to do a difference of 2 squares. And then I bring the x minus 1 down. So this is another factoring by grouping that gave me 3 binomials as my answer. Okay, let's look at the next one. Parentheses over the first 2 terms, parentheses around the second 2 terms. So my first 2 terms, pulling out a GCF, it's going to be 3x squared. So I'm going to divide them both by 3x squared. It gives me an x left over for my first and a negative 5 for my second term. Then I'm going to look at my next one. I can pull out a positive 4. When I do that, it leaves me with an x minus 5. My parentheses match. Yay, they always will match. My answer includes the first common set of parentheses and the 3x squared plus 4. The only x squared I have here is 3x squared plus 4. It's not difference, so there's no subtraction, and 3 is not a perfect square, so that one's out. So my answer ended up just being a set of 2 binomials. All right, I'm going to pause this video and we're going to start another video because I have a time constraint. So we will do the next 4 examples 3 through 6 on my next video.